All right, so some of you may still be writing, but I'm going to go ahead and start. So, in the last two lessons, we started talking about how we can use equations to model real world situations. Okay, so we did that with our pizza parties, we did that with the blueberries and the earnings and all of that stuff. So, what we're going to do is we're just going to continue that today. So, right here in lesson three, says we're going to be writing equations to model relationships. This is just part two of it. All right, so in your goal, it says we're going to identify and describe patterns in tables of values and in calculations. Okay, and when we find those patterns, we're going to use them to find relationships, and those relationships are going to help us create equations. Okay, so give me a thumbs up if y'all have that finished, if y'all have finished writing your goals. Awesome. All right, and I am recording this, so you can always go back and get those later, okay? So let's look at 3.1. So we have a table here, and we have two quantities. We have X and we have Y, okay? Those are here, and they are related. That means there is a relationship between these quantities, okay? So when you first learned about X and Y tables, you probably learned about them as input and output tables, right? Does that sound familiar? Input and output tables? That means you start with your input, which is 1, 3, 5, and 7 in this case. You do some sort of operation here, and then it produces your output, which is these values right here. Okay? So that's what we're going to kind of be looking at here today. That input output, that operation that's happening is the relationship that tells how they are related. Okay, so I'm going to give you all a minute or two, and I want you to look and see if you can find a relationship between our X and Y value. Okay, I just want you to see if you notice anything about this table, anything that stands out to you, that you could tell me how these values are related to each other. Okay, so don't overthink it right now because we will talk about it, but I'm going to give you all about a minute and then we will talk about it together. All right, y'all have about 30 more seconds. Y'all are doing great. All right, so someone tell me something they notice about this table that we're working with. What do y'all notice about this table? Y'all have to unmute yourselves. Y'all notice any patterns or anything going on in the table? What do y'all see?
All the input ones are odd and all the output ones are even.
Okay, so all these values are odd. All of these are even. Good. All right, what else do you notice?
They're not evenly multiplied.
Okay, so explain what you mean a little bit, Caden.
So, like, you can't get 8 if you times 3 by whatever the number is. You can't get 8 at all.
Okay, so the y values are not multiples of the x values. Okay, so we're not just, so the relationship that it's talking about is not just taking our x and multiplying it by something to get our y. Good. Anything else before we go on? Okay, sorry, I'm trying to bring up something on my other computer. Okay, so one thing I noticed here is that when we're looking at our x values, a lot of people notice that it's increasing by 2. Okay, and so then sometimes that will point us to a pattern where then these will be increasing at the same amount. Okay, so this is increasing by 8. Oh, but this is increasing by 16. Okay, so right here it asked us, what are some strategies? Okay, so some strategies that we could use are finding patterns by comparing the x and y values. Okay, but when we do that, did we find the same pattern? Is this the same pattern?
No.
No, it's not a consistent pattern. Okay, so you can find patterns to help you find the relationship, but that doesn't always mean that that's going to point you in any direction, because we found a pattern, but it doesn't tell us the relationship. Okay, so I'm going to keep those. Okay, another way we could use strategies to find relationship is that we see if there is an operation that could be done to the x values to produce the y values. Okay, so that is another strategy that we could use. Okay, so there's lots of different things that we could do to find that relationship. So can anyone see maybe what operation we're doing to our x values to produce our y values? See that relationship? Take a second and look. What operation are we doing to all of these x values to produce the y values?
We're doing addition.
Okay, what do you mean?
No, never mind. You're actually doing multiplication because
You're muted, Caden.
so like you're you're doing +2 on everything. So wouldn't that mean you're multiplying by 2 on everything, or would it mean you're just adding to the values by 2?
Well, if we add each value by 2, then that's not going to produce the y value. I'm saying, what do we do to our x to equal the y value? So we're looking here. What are we doing to 1 to equal 0? What are we doing to 3 to equal 8? Do any of y'all think y'all can figure out what that is? It's not an easy one. Okay, I've only had 2 people figure it out. Do y'all want me to give y'all a little bit of time, or y'all want me to tell y'all what it is?
Tell us what it is.
Okay. Okay. All right. So what we're doing is we're taking this number x and we're multiplying it by itself. Okay. So we have 1 times 1. And what does that equal?
1
1. All right. And then what would we have to do for it to equal 0?
minus by 1.
Minus 1. So we took it, we squared it, and we subtracted it by 1 and equaled 0. Okay, let's see if that same relationship works down here. All right, so we have 3 squared. What's 3 times 3?
9.
9.
And then we minus 1. Does that equal 8?
Yes.
Okay, well, let's keep going. Let's see if it works for all of them. So we have 5 squared, which is what?
10.
24.
25. Minus 1 equals
24.
24.
24. Remember, squared is that base number times itself. So that's 5 times 5. And then finally, we have 7 squared, which is 49. Minus 1 is
48.
48. Okay, so that's what it's talking about up here in our goals when we describe patterns. Because that same pattern worked throughout our entire table, then it forms a relationship which we can then use to write an equation. So writing our equation, what did we do to our x value every single time?
You added 2 to it.
We added that squared. Okay. All right. And then what did we do to the x value?
We added 2.
We didn't add 2. I'm saying, what did we do?
Subtracted 1.
We subtracted 1. And that always equaled our what value?
Or y value.
Y.
Our what value. Good. All right, so this one is a very high level, like, equation model, okay? I'm not going to expect you to come up with these just yet, okay? That one was a little bit difficult, but I did have a couple of kids who got it in some of my other classes, so I just thought I'd bring it to your attention. So we found a pattern, it described a relationship, therefore we could write an equation. Okay, let's practice it a little bit more with these they're a little bit easier tables. Okay, so right here it says we're going to describe in words how the two quantities in each table are related. Okay, so we're going to talk about how they are related again. Okay, so let's, just like in Unit 1, we need to talk about, what's the word I was looking for? How important it was to know the titles of graphs. So we can talk about it. It's for tables. You need to know what you're talking about. All right, so what does our x value represent here?
Number of laps.
Number of laps. Good. What does the y value represent?
Meters run.
Meters. Good. Okay, so if I have ran 0 laps around the track, how many meters have I ran?
0.
0. Okay, so that makes sense. All right, so what happens the more laps I run around the track? What's happening to my meters? So my number of laps is increasing. What's that going to do to my meters? Doing what? It's increasing. Okay, so that's all we're going to do is we're going to put it into words. We're just describing the relationship. So we notice what's happening between those quantities. Okay, so let's write it down. As the number of laps increases, the number of meters ran increases. Okay, so let's do one more just to make sure that y'all got it, and then I'll let you do the next two on your own. All right, so let's look at table. All right, what is our x value talking about?
Meters from home.
Good. What is our y value talking about?
Meters from the school.
Good. All right, so right here it says 0. So when it says 0, what does it mean about where we're at?
You're at home.
We're at home. Okay, so when we're at home, how far away from the school?
We're 400 meters away.
We're 400 meters away. Good. All right, so what's happening as when we go to 75?
Our meters from school decreased to 325.
Okay, so then what happens when we our distance from home increased again?
We're getting closer to the school, so we're 272 meters away from school.
Okay, so let's put that into words. As we get further from home, what happens? What happens as we get further from home? Where are we going?
We're going to school.
Okay, we are getting closer to the school. All right, another way you could have put that is you could have said, as the meters from, oops, you don't have to write this one, as the meters from home increases, the meters from school decreases. Okay? Again, you're just describing the relationship of those quantities. All right, so I'll come back up to this in just a second. If some of you are still writing, I need y'all focus, looking at your screen. All right. You're going to do these two. You're going to describe them in words, and then you are going to, if you finish before the timer runs out, see if you can answer number 2. You're going to match each table to the equation that represents the relationship. All right, so I'm going to give you all a couple minutes to do it, and then we will talk about it. Ready, go. All right, I'll have about 40 more seconds to get those done. Remember, if you finish, go ahead and start on number 2, matching the equations to the correct table. If you don't know how to do that yet, don't worry, we'll get to it in a second. If you are finished with both of them and you want to send me your answers, you can send them to me in GoGuardian, the GoGuardian chat on Google Chrome, like the internet thing. For some reason, my Zoom's not letting me have chat today, so it makes it a little difficult. Right, let's see here. Look back up. No, sweetie, you gotta leave it on. Okay, let's look at it. Part C. Someone unmute yourselves, and please unmute yourselves. I know that y'all answer more questions in class. Someone tell me what table C is talking about. What is table C talking about?
Electricity bills.
Okay, what about them? What happens as the electricity bills increases? As the electricity bill increases, what happens to my total expenses? What's it doing?
It increases as well.
Good. The total expenses increases. All right, now let's look at D. What's happening in table D?
I said as the monthly salary increases, the amount of deposit decreases.
As the monthly salary increases, the amount deposited, okay, it doesn't decrease. It's also increasing a little bit. All right. So all we did there was it wanted us to describe it in words. What's the relationship between those two quantities? Okay. Now on part 2, it says match each equation that represents the relationship. So we have equation 1, 2, 3, and 4 here. Okay, and we know that a equation just describes the relationship between variables, okay, between quantities. Okay, so in this equation, it's saying 400 plus our x value should always equal our y value. All right, so let's look at this first table here. We have our x value, which is 872. And we're going to add 400 to it. And according to this equation, it should equal y. Is 872 plus 400 472? No, it is not. So does that equation represent this table?
No.
No. All right, so let's look at C. All right, it says our x value, which is 85, plus 400 should equal our y value. Does it?
Yes.
Yes, it does. Okay, but let's not just jump the gun on the first one because like we saw in our first table, we have to find a pattern. So it has to work through the whole table. Okay, so let's try it for just one more just to make sure. Is 124 plus 400 524?
Yes.
Yes, it is. Okay, so equation 1 goes with which table?
Table C.
Table C. Okay, so I want you to do the next 3 on your own. And when you got them, please send them into the Go Guardian chat.
What?
you have your cell phone out? I need you to put it in your backpack.
All right, so we have equation 2. Someone unmute themselves and tell me what equation 2 would match with.
D.
D is correct. Let's check. It says that we're taking our x value, which in this case are all of these top numbers, and we're subtracting 400. Is 872 minus 400 472?
Yes.
Yes.
Okay, so that one works. All right, what about equation 3?
B.
B.
Is B. Good, so let's double check. We're going up here. We have our x value plus our y value should equal 400. Is 0 plus 400 400?
Yes.
Is 75 plus 325 400?
Yes.
Yes. Okay, so that one works. That means that which table what would go with equation 4?
A.
Okay.
Okay. Awesome. All right, so we've started looking at all of these different relationships. So we can see that sometimes we have our quantity, our x or our y value, that we subtract an amount or add an amount to equal the other. Sometimes it's the x and the y working together to equal something. Okay, so there's always some sort of operation going on between our x and our y to form a relationship. So here we are at 3.3, and we're going to try to find the relationship in this table. So this table represents the relationship between the base length and the height of some parallelograms. And both are measured in inches. Okay, so our base lengths here represent our x's, and our height represents our y values. Okay, if you wanted to, you could do base lengths is our b and h is our height. It doesn't matter, whichever one you wanted to do. All right, so right down here it says, what is the relationship? So there is a relationship between the b and the h of these parallelograms. So I'm going to let y'all look at that. I'm not going to give y'all super long just so we can keep moving forward. But I'm going to give y'all about a minute. I want y'all to look over that and see if you can see what that relationship is between in that table. See if you can find what's going on there, and not only what's going on in one of them, but it works for every one of them. All right, ready, go. If you think you have it, send it in the chat. What he got with it. Does anybody else think they know what that relationship is? All right, Caden, what is the relationship in this table?
Base length and height are multiplied to equal 48.
Good. The base length times the height multiplies, and it gives us 48. Okay, so that works for the first one. Let's see if it continues. Did that work? Is that true? All right, good. Is that true for all of them? Class?
Yes.
Yes, it is. It worked for all of them. So that is the relationship. We found the pattern. Now we can take that and form it into a relationship. So how can we write this so it is true for any base length or any height? What could the equation be for any base length or any height? What could we put? What if we didn't know what the base length was? What could we use instead?
You could just say X.
We could say X. All right, then what did we do with our X values?
We added them to the last one, and then we kind of halved it between 4 and 8. So like when you basically times it by 1.5 because 4 times 2 equals 8.
No, I'm saying what did we do to our 1 and our X here? We did 1 time, or we did our X value times our Y value, right? And that equaled what?
48.
48. So when you're trying to find a relationship, you're going this way. You're going X to Y. X to Y. X to Y. X to Y. Okay? It's whatever's happening to those values to produce an answer. Okay, we've got one more and then we're doing the lesson summary. So stay with me. All right, we're not doing number 3. All right, number 2 is one like we've had in homework. So y'all really pay attention because I'm going to make a prediction here that a lot of y'all are going to do this backwards. Okay? And I only say that because everyone in all my other classes have. Okay, so really listen to me while I break this down. It says visitors to a carnival are invited to guess the number of beans in a jar. Okay, we've all done that. We've all guessed how many beans are in a jar before. The person who guesses the correct number wins $300. Okay, so who wins $300?
The person who guesses the right amount of jelly beans.
Good. Okay. But in this situation, if multiple people guess correctly, the prize will be what?
Divided evenly among them.
Good. Okay. So let's just say, okay, so it's divided evenly among them. Yeah, let me stop there for now. All right, so it says, what is the relationship between the number of people who guess correctly and the amount of money each person will receive? Okay, so these 2 things that I just underlined in red are the quantities that we don't know yet. So what do we use in place of quantities that we don't know yet?
For X and Y values.
Our X and Y values. Okay, so we'll say that the number of people is our X and the amount of money is our Y. Now, you could have made your variables any amount or any letter. Okay, I just chose X and Y. All right, so I'm going to give y'all about a minute to see if y'all can come up with it. If you get it before the timer, send it to me in the chat. Ready to go. You have about 20 more seconds. See if you can come up with it. All right, so let's look at it. I want us to take a break from this particular problem real quick, and I want us to put it in a real world situation. All right, so we all did this in our class. Let's say we all had a jar of beans in our class, and the prize was $300. Okay. Let's say it says if multiple people guess correctly, the prize will be divided evenly. Okay. Well, let's say that 5 people guess correctly. Okay, 5 people guess correctly. All right, so what am I going to do with this 300?
Divide by 5
evenly among the 5 people.
I'm going to divide it by the 5 people. All right, and that's going to tell me how much money they earned. All right, but Which one of these two values did I not know in the original problem?
How many people guessed it correctly?
How many people guessed it? Okay, so instead of using 5, oops, sorry. Instead of using 5, what am I going to use?
X.
All right, and that's going to tell me how much money they made, which we said is our Y. So it's 300 divided by X equals Y. All right, does that make sense to everyone on how we got that? I need a thumbs up, a thumbs sideways, or a thumbs down as just a quick way to kind of see what's going on. All right, I can't see a lot of your cameras. All right. So that's all for lesson 3. So go to page 150. Okay, so sometimes the relationship between two quantities is easy to see. So that could be like the one second. All right, so that could be like when we were looking at the tables and we had the X and the Y, these tables up here. Okay, those are really easy to see because there was only one operation happening between your X and your Y values. Those are really easy to see. Other times, the relationship between two quantities might take a bit to work out. So you can do that by doing calculations several times or by looking for a pattern. Okay, those are some of the strategies that we talked about. All right, so it gives us 2 examples here. This is example 1. We have a plane departed from New Orleans and is heading to San Diego, and the table shows its distance from New Orleans, X, and its distance from San Diego, Y. Okay, so this is our X, this is our Y. All right, this is very similar to that home and school table that we looked at earlier. The farther we got away from the school, or the farther we got from home, the closer we got to the school. This is the same situation. The farther we get from New Orleans, the closer we get to San Diego. All right, so it says, what is the relationship? Well, down here it says, notice that every time the distance from New Orleans increases, the distance from San Diego decreases. And then the sum of the two values is always 1,600 miles. All right, now it says the relationship can be expressed with any of these equations. All right, so right here is the obvious one. It takes your X value and your Y, it adds them together, and it gives you 1,600. All right, but then why does it also say that these 2 equations also work? What are those examples of that we talked about the other day? Give me a hint. It starts with an E. What would that be an example of? It's an equation that looks similar. I mean, that has the same value, but it looks different. I'm sorry. An equivalent equation. All right. So basically, each one is going to tell you the correct value of something in the situation, but each one is rearranged and solved for a different variable or a different quantity. All right. And then finally, we have this situation here. It says a company decides to donate $50,000. Oh my gosh. Oh. $50,000 to charity, and it will select up to 20 charitable organizations. Each organization will receive an equal amount of donations. By the way. All right, it says, what is the relationship between the number of selected organizations, which they have named N, and the dollar amount each will receive? Okay, so when it's talking about N, it's talking about the number of selected organizations. And when it talks about D, it's talking about the dollar amount each will receive. All right, so it gives us these 3 little bullet points here. So it says if 5 organizations are selected, that's N, they will receive $10,000. That's D. So we're taking that 50,000, we're dividing it by the number of organizations, and that equals the amount of money donated. Same for the next one. We have 10 organizations, and that's $5,000. All right, do y'all notice a pattern in how we solved that each time? What did we do each time in this problem?
Division.
We did division each time, okay? We took that 50,000 and we divided it by the number of organizations that we were working with, okay? So they came up with this nice little equation to model that relationship, okay? So that would be the equation that represents it.